how to graph a limacon. So let me give you some tips. Let's say I gave you this equation. It's an equation of a limacon, and I asked you to graph it. There's two ways to look at this. One of them would be just to make a t-chart. And remember before what we did was we had our r value, our theta value. I'm sorry, we had theta. We had what is cosine of theta and what is r. So if theta is 0, pi over 2, pi, 3 pi over 2, or 2 pi. And then we remembered, we recalled that we have a cosine graph. Here's our cosine graph. And when cosine is 0, when theta is 0, cosine of 0 is 1. When theta is pi over 2, so that's this point right here. When theta is pi over 2, cosine of pi over 2 is 0. When theta is pi here, so this is pi over 2, cosine of pi over 2 is, cosine of pi is negative 1. When theta is 3 pi over 2, cosine of 3 pi over 2 is 0, and then we're back up to 1 at 2 pi. Okay, so remembering your points there. Now all I have to do is plug in values for this equation. So when theta is 0, then it would be 3 minus 5 times 1, which would be negative 2. When theta is pi over 2, then we're plugging in 3 minus 5 times 0, which gives me 3. When theta is pi, I'm plugging in 3 minus 5 times negative 1, which gives me 8. And then at 3 pi over 2, I'm plugging in 3 minus 5 times 0, which is 3. And then the last one would be the same as the first one, back to negative 2. Now, graphing this, I'm graphing the points negative 2, 0, 3 pi over 2, because remember it goes in the order r theta, 8 pi, 3 pi over 2, and then the last one would be the same as the first one. Negative 2, 2 pi would be the same as negative 2, 0. So I'm going to plot these points. So here's 0, pi over 2, pi, and 3 pi over 2. So 0, negative 2 would be 2 in the opposite direction from 0. 3 pi over 2 would be 3 in the direction of pi over 2. 8 pi would be 8 in the direction of pi. So 1, 2, 3, 4, 5, 6, 7, 8. So here. And then 3 pi over 2 would be 3 in the direction of 3 pi over 2. Now, this by itself doesn't tell you a whole lot about the graph. You have to remember that when you have 2 points that are on the same side of the pole, that gives you a loop in the limacon. So this is a limacon with a loop. You also have to remember that the limacon goes wider than what we see here. So if we actually graph this, it's going to be more lima bean shaped. Remember, it's going to have a loop in it in the middle. So that would be what the graph looks like. So that's one way to graph a limacon. Now there's a second way to graph a limacon, and that is to recognize that is to look at the equation. I think I'm just going to start this over on another page and just show you the other approach. So we're starting fresh here on this page, show you the other approach, is to remember some things about cosine and sine. So recall our circles. R equals cosine theta, r equals negative cosine theta, r equals sine theta, r equals negative sine theta. Where did those circles end up? Cosine theta was over here. Negative cosine theta was over here. Sine theta was up and negative sine theta was down. So that tells me when I see this negative and the fact that it's cosine, that I'm going to have a graph where the majority of the graph is to the left of the pole. The second thing I want to know is where is cosine equal to 0? So here I've got, okay, so my majority of my graph is going to be to the left here. This number here will tell me how wide the graph is, which means I'm going to be going 3 in this direction because the width of the graph is going to be up and down, since the basic graph is going to look something like this. Okay, it's going to be that way. So here's, I'm talking about these 2 points, this width and here. This is going to be 3 and this is going to be 3. Now this distance here, the biggest distance from the pole, how big can it get? Well, if cosine is, if cosine of theta is equal to -1, then this whole value is going to equal 8. And where does cosine equal -1? At pi. So at pi, 2, 3, 4, 5, 6, 7, 8, I'm going to be at my biggest value, and that biggest value is going to be 8. That's the biggest I can get. It'd be 3 minus 5 times -1. Now, what's the smallest value I could get? Well, the smallest value is going to occur when cosine of theta is equal to 1. And cosine of theta is equal to 1 at 0. So when cosine of theta is equal to 1, it's going to be 3 minus 5, which is -2. So that tells me I'm going to have 0, -2. Now, I also can tell that it's a loop. If this second number is bigger than the first number, not worrying about positive or negative, but if it's just bigger, there's always going to be a loop. If it was 5, 3 instead of 3, 5, it would still go out to 8, but there would not be a loop. Instead, it would go 2 in the opposite direction. So this is just another way of looking at the graph, and if you watch the video about the summary of polar graphs, you'll see a lot of characteristics of limacons and cardioids that would help you to graph this way. I don't care which way you do it. If the pattern, if this makes sense to you, it's shorter probably than graphing by plotting points, but if this does not make sense to you, then you can always plot points. It is helpful to know, however, that when you see this -5 cosine theta, that the biggest part of the graph is going to be to the left. That's a good check to make sure when you plot points that you are getting the correct graph. So hopefully that was some helpful tips for you about graphing limacons. And practice with some of the graphs that I gave you in the review sheet, and that should really help too.